of mathematics. Now we discuss about the topic graph theory. First, we are going to see about what is graph. A graph is a collection of vertices and collection of lines and edges, each of which joins their points of single points to itself. That means we are denoting as edges and vertices. Next one. To introduction to graph, this is the example of graph. It means we are denoting as vertices and edges in the graph. That is V1, V2, etc. V4 and edges as 7. Next one. And self-loop and parallel. That means loop means the starting point and ending point are same, and parallel edges means there have the multi edges in a graph. Next one. A multi-graph and simple graph. It is neither that a simple graph and simple loop and parallel edges are said to be a simple graph. This is the example of simple graph and multi-graph. Next one, a weighted graph. If each edge or each vertex or both are assigned with same positive numbers, then the graph is denoted as weighted graph. Next one, a finite and infinite. A finite is we are counted as the number of vertices and number of edges, and infinite is we are labeled as G. Adjacent and incident. Two vertices V1 and V2 of graph G joined directly by edges and their vertices are adjacent. And then the example is G1. That means V1 and V2 are adjacent vertices. The definition of in the incident, the V1 is a vertex of edge Eij equal to V1 and Vj. Then the edge Ei is said to be incident on Vr. Similarly, Vi, Vj is said to be incident on Vj. For example, the graph G, E1 is incident on V1 and V2. Next one, that is the degree of vertices. The number of edges, incidence of a vertices V1 with self-loop counted twice is called a degree of vertices. For example, consider a graph D of V1 equal to 3. That means a vertices V1 contains two vertices. That means V1 and V2. Next one, the matrix representing of graph. A graph can also represented by matrix. That means adjacent matrix and incidence matrix. Next one, adjacent matrix. Adjacent matrix is a parallel edges is symmetric. Binary matrix, that means it satisfies the condition A of G equal to Ai Aj on the order of n cross n matrix, which is the example of A of G equal to, that means row vertices and row columns. Next one, incident matrix. A given graph G with n vertices, E edges of non-self loop. The incident matrix satisfies the condition x of G equal to Xij of the order G is an n cross E matrix, which is the example given here. That means E edges, V vertices. V of G equal to these rows and columns. Next one, in a direct and digraph representing here, if each edges of a graph G has some direction, is said to be a digraph. In a graph which directed edges within in degrees and out degrees, which is denoted as degree of minus of V and degree of plus of V. Next one, in a direct graph, which is the example of this direct graph, which has the direction and inside and outside also. And next one, adjacent matrix of a digraph. It is defined as similar fashion as it defined for undirected graph. Which are the examples? This is the direction and does not have that same direction in a graph. Next one, incident matrix of a digraph, which is the examples which given for xi equal to -1 and xi equal to 0. Next one, null graph. If H set of any graph with n vertices is empty set, then the graph is null graph. If in a null graph there is no H vertices and it is denoted as null graph. Thank you.